For as long as we've had cars, they've caused negative impacts on the environment. Scientists have been working hard to create an environmentally friendly mode of transportation, electric cars. So, using the aspects of physics, chemistry, and biology, we'll explore how these new vehicles really work.
At the physics portion of an electric car. Now there are four main forces that is acting on an electric car at all times. First we have force normal, which is pushing up from the surface. Then we have force gravity, which is pushing down from the middle of the car. We have force forward, which is pushing the car forward. And then we have force backwards, which is pushing the car forward by pushing the ground backwards. Two other forces that are working on the car is force of friction and force of air resistance, which are both pushing the car back. Let's talk about the different parts of the car. So first we have the battery, which provides electricity to power the vehicle. Next we have the DC converter, which converts high voltage DC power from the batteries to low voltage DC power. Next we have the electric traction motor, which drives the wheels and performs regeneration functions. Next we have the onboard charger, which takes AC electricity supplied from the charge port and converts it to DC to charge the battery. It also monitors the battery characteristics. Next we have the power electronics controller, which manages the flow of electrical energy, and it controls the speed of the motor. Finally, we have the transmission, which transfers mechanical power from the electric traction motor to drive the wheels. Now let's talk about how it works. So if the car is accelerated, the controller delivers energy to the DC motor, which causes the car to move forward. If the driver takes the foot off the acceleration, the controller delivers 0 volts, which causes the car to slow down. Finally, if the driver brakes, regenerative braking will take place. Regenerative braking is used in electric cars, which means when a normal car is slowing down, the kinetic energy is converted into heat. But in an electric car, some of that kinetic energy is captured and turned into electricity, which is then stored in the batteries. Some energy will always be lost, so the mechanical advantage will never be perfect, but it most definitely helps. Let's talk about the energy of the car. So when braking, kinetic energy and the vehicle's inertia turns an electric motor generator on, which changes the energy back to electrical and stores it back in the battery. When there is no heat energy from gasoline used, which means that all energy has to be used to power things like warmth in the cabin, must be run by electrical energy as well. When the car is idling, the motor automatically shuts off, causing almost no energy changes when idling.
The motor spins, the wheels rotate, pushing the car forward or the ground backward. The motor causes the main acting force.
The chemistry section of electric cars. There are many chemical transfers that go through in an electric car. When it starts, energy goes into the battery, which converts chemical energy into electrical energy. Electrical energy then goes to the controller/inverter, which converts electrical energy back to electrical energy, and then into the motor, which converts electrical energy to mechanical energy. We'll look further into the batteries in electric cars, which are specifically lithium-ion batteries. A lithium-ion battery is comprised of two oppositely charged electrodes, the anode and the cathode. As the battery releases energy over time, lithium ions, which store a lot of energy in their bonds, travel over a separator and drop electricity out. Then, when charging, the lithium ions go back over the separator in order to continue the cycle. These lithium-ion batteries have a lot of advantages over traditional batteries, as they lose very little energy over time and charge relatively quickly. The inverter in an electric car has a single purpose, converting the 300-volt DC battery to 240 volts AC, something that the motor can use. So the car, like most devices, requires AC because it travels further than DC does. A converter really only has one purpose, and the inverter's purpose is to switch from DC to AC. The converter is to switch from 300 to 240. Lastly, I'm going to talk about the controller. So the controller in an electric car happens to be the pedal. When you push the pedal all the way down, the reading reads 100% output of 1, which means that the car is always receiving electricity. But if you press the pedal halfway down, it'll read something like this graph, where it is on half the time because the pedal is pushed halfway down and off half the time. The controller outputs a sine wave that that can pulse up to about 15,000 pulses.
Connection time.
And electrical energy transfers in what contributes to a more environmentally friendly car. Traditional cars have more chemical energy transfers, which is more impactful on the environment.
Electric cars also have many biological benefits. Electric cars have several benefits over conventional internal combustion engine automobiles. One of the benefits is that when you get an electric car, you are lowering your local carbon emissions. The excessive amount of carbon being released into our atmosphere is the main contributing factor of global warming. And then here in this picture that I drew, these are the sun's rays shining onto Earth, and Earth absorbs some of those sunlight rays, but also some of them get reflected. And here it is bouncing off Earth's atmosphere. And because of the excessive amount of carbon emissions in Earth's atmosphere, the light and the heat gets trapped, therefore increasing the temperature of our Earth. Okay, so this graph represents the global carbon emissions from the 1900s to the 2000s. The y-axis here represents the million metric tons of carbon emissions released into the atmosphere, and then the x-axis represents the years. And as you see in this graph, there's a drastic upward trend up until the present day here in 2019. And if we are able to incorporate electric vehicles into our daily life, these numbers are expected to drop by at least 32%. Throughout this project, we learned...
Wait! We forgot.
It's connection time!
Regenerative braking occurs through changes in energy which saves the environment from fuel and heat emissions into the air. Regenerative braking positively impacts biological factors. We learned about how different kinds of science contribute to the functioning of an electric car.
Callie taught us about the different forces acting on an electric car and the different energy transfers.
Jackson taught us how lithium-ion batteries function and how different components use different types of energy.
Braden taught us how different functions of electric cars can lead to a decrease in the carbon emissions in the environment.
We hoped you learned about electric cars and how they work. Electric cars are the vehicles of the future. By using these new cars, we can reduce the environmental impact in the future.
Thanks
for watching.
Let's go!
Three, two, one, action. We learned about how different kinds of cars. I said the wrong line anyway. Three, two, one.
Taught us how lithium-ion batteries... What? Wait, what? Was that doing something wrong?
We were so close. We were so...